Alright, this quick video is on function notation in graphs and how function notation applies to graphs. So we've got two different graphs here. We have the first graph, which is the graph of f of x. That's what our function is named. It is a linear function, and we know that because it makes a line, okay, and it has a negative slope because it's going from the top left to the bottom right. Our second graph here, g of x, is a cubic function, and we know that because the graph is changing direction 3 different times. It starts going up, changes to going down, and then goes back up again at the end. So it's a cubic function, has a degree of 3. Now what we're looking at in this video is we want to evaluate different function notations. We're going to start with f of x. We've got two examples here, f of negative 2 and f of 4. Now what this means is we want to figure out that this negative 2 here is our x value. Now if we had the function defined, if it told us what it was, say f of x equals 6x minus 7, we could plug in the negative 2 and evaluate and figure out what the answer would be. We don't have that. What we have here is the graph. So we're going to look at what's in the parentheses, and again that's our x value, and we're going to find that on our graph. So we're looking at, we want to know what f of negative 2 equals. Well, I found negative 2 on our x-axis. I'm going to follow that up and then follow it over and see what the y value is. And that would be the answer to our problem. So if we look, 1, 2, 3, 4, 5, 6, that's really 6 up from the negative 2. If we go to the negative 2 on the x-axis, the graph is 6 points up. So then the answer here is 6. That ordered pair would be negative 2, 6. The negative 2 is the x value. The 6 is the y value. Alright? That's what we're looking for. We're looking for the y value. What the y value of the ordered pair would be. Let's look at 4 now. f of 4. So we're going to find the x value of 4, which is right here. We're going to follow it down and then follow it over and see what that y value is. Well, it's at negative 3. So the ordered pair here would be 4, negative 3, and the answer is just negative 3. Alright? The g of x ones, same idea, just a different shaped graph. We want to find g of negative 3. So we're going to find the negative 3 on our graph, follow it up, and then follow it over. Now, using your skills on interpreting graphs that we learned the other day, that's a relative maximum because it's a high point. It's at negative 3, and then it's up 2. So the ordered pair there for that relative maximum is negative 3, 2. So the answer is 2. One more, g of 0. Well, 0, we're not going anywhere. We just need to follow it down and see where it hits the graph. We're looking for the y-intercept on this case. Another thing from the other day when we interpreted graphs. So if we look here, the hit's at negative 1. The ordered pair there would be 0, negative 1. Again, the y-intercept. So the answer here is negative 1. Keys to function notation and looking at graphs is to remember whatever's in the parentheses is the x value. You're looking for the y value. If you put those two together, it'd be the ordered pair on the actual function. Alright? And we've listed those out in our graphs. So again, you want the y value from an ordered pair on the function. If you have any questions, go back and rewatch this. If not, bring them to class next time.